It's Aaron 313. GitHub. Here, I'll send it to you. Yeah, AARON 313.
Sorry, 1313?
313.
I like that.
Yep, just like that.
I'll have that as soon as I see the repo.
I'll check in the code after.
Okay. Boom. We are streaming muted. Nope, we're not muted. There we go. There's not really a Python video and not really a Python meetup downtown, so we decided to start one in Sugar House, and that was at Zinniac, and then it kind of migrated a few places, and now we're at the U, because everybody loves to drive to southern Salt Lake City during rush hours. So that's why we decided we would try to do a downtown meetup. However, there is Python at the Point. That is a meetup that everybody should check out. Let's see. Usually I scroll down as I talk. I'm tweaking some of this tech stuff lately. You might notice that this isn't Mozilla's Etherpad. We now have our own Etherpad. Yeah. Yes. Finally. I learned how to code, guys. Finally. Yeah. We have Python Utah North. That one's run by a guy who looks very similar to me, but very little relation. He is my dad. That one's out of Logan, Python Utah North. They will be meeting next Thursday. Salt Lake City PyLadies. Any of the PyLadies here? Hi, PyLadies. What up? You gotta shake your arms in the air. I don't know. I'm tired. Okay, it's office. Yeah. So, do you know when the next meetup is for that one?
Yeah, we meet the last Wednesday of every month, and this next one in August is going to be awesome. It's going to be Intro to Machine Learning, taught by Missy here, and it's open to Ben, so anyone's welcome.
It's open to all genders,
yes.
Open to everybody.
All humans.
Salt Lake, Python at the Point, South Valley. So if you do feel like driving south, you know, you can always go here. This one's at Canopy. I think I got it right for once. Yes, I got it. Who's from there? Anybody? Anybody represent? Yeah? So that's at Canopy, right? Yeah. Details right here. That one, is that still run by Herlo, or is somebody else running it now? I don't know.
I don't know the face.
Well, I should back up a little bit. Utah Python is the umbrella thing that kind of sponsors all the northern Utah Python meetups in the Wasatch Front. So that's us. Anytime you're making a donation, you're also donating to Python Utah North and Python at the Point. We keep their site up, we keep their meetup page up, all that other stuff, and all those fees. All of those are listed at meetup.com/slcpython/money. There should be a link in here, but all of our accounting is open. The only thing that you don't see is particular donors unless they're a sponsor. And that will be updated tomorrow. I didn't have a chance today to update that. Let's see. Oh, and this is an Etherpad. So if you don't know, there should be a comment in the meetup right now. A lot of people are actually on it right now, so they're able to see it. And you can edit this if you want. So once we get to the section where we're looking for people who want to find work, put in your contact details in there. Yeah, let's keep going. Girl Develop It. Anybody from Girl Develop It, SLC? No, not this time, eh? Well, Girl Develop is more workshop oriented, as opposed to PyLadies, which is more speaker oriented, kind of like this kind of meetup.
No, we do hands-on stuff.
Yeah.
All the time.
Well, I know PyLadies are badass, so they do everything. Okay, so whereas ours is presentation oriented, Girl Develop It is much more workshop oriented, and then clearly PyLadies is everything. So. So yeah, they're around. Definitely check them out. Give them a holler if you ever want to teach a course. There's also a very new meetup. They're about to have their third meetup, the Salt Lake Data Engineering Meetup. Now, fun fact about me, since I moved back to Utah, I've only participated in one meetup, and it's this one, gasp. And I know you're supposed to participate in all the meetups, but I don't know. It's hard to be a meetup founder and also go to meetups, but I went to this one. I know, right? It's crazy. So I went to this data engineering meetup, and we had an awesome speaker, and that one was at, where was that, Pluralsight?
That was a Pluralsight.
Yeah.
So we'll be having the next one will be on August 15th at Ogersock, and Dylan Gregerson will be talking about hierarchy of data science needs.
Nice.
So
that's a good talk. Our very own Dylan. He grows up so fast. And then there's also the PyData SLC meetup. That's right here. This one I don't know too much about. Somebody just linked it. So, yeah.
So I went to it last, when
yes.
it's the first meeting. It was Travis Oliphant. He's the one that was the founder of Anaconda and SciPy and NumPy.
Nice.
So we're just trying to get this started
So
in
they
Salt
got
Lake.
some small fry speakers. Just kidding. Our website's slcpy.com. So everybody knows the running joke for this one, right? That I don't know where it went. I lost the server. I didn't. I found it. Finally found it. I got it up. Okay, let's look at it. It's a Django 1.3 site that's been running for 4 years without anybody looking at it. Let's see what it looks like, shall we? Should I click it? See what happens? Yeah, so I updated it a little bit. I put it under construction because I found it 2 days ago. For now, it's like this. Hopefully in the next couple weeks, I'll be updating it again so it'll like pull and have our homepage and things like that. I'm using Dokku. Has anybody used Dokku before? D-O-K-K-U. Has anybody used Heroku? So Heroku is awesome. You just like put a file and you're like, hey, I need this to run. Just run it for me. And then you just get pushed to Heroku. Dokku's the same thing, but you get to host it. So yeah, so our website cost for now is going to be about $10 a month, and that's $5 for the Etherpad and $5 for just the website. Hopefully in the next 4 months, as we get our 501c3 stuff lined up, all that nonprofit stuff lined up, Xmission will then be able to host our site for free. So that'll be cool. But for now, yeah, it's a $10 a month charge. That's not too bad. UtahPython.org is in Angular. That one's statically hosted. We're probably going to move that over too. And that should be like nothing. We'll just put it on the same server. It's in Angular, should be React, I guess. Somebody wrote should be React. Huh. I did not write should be React. It should be Python, right? Yeah. Our GitHub repos, here's the SLCPython one. So for example, if you go to github.com/slcpython, you'll see old.slcpy.com, and you'll say, whoa, somebody accidentally checked in your Meetup API key. Oh, well, yeah, so somebody checked in a secret key. I fixed that. And then this is like the UtahPython one. You can make PRs, you can make requests. If you want to work on this Django site with me, hit me up. It's very straightforward Django. It's literally just going to be templating at this point, and I just haven't had time. Sponsors, Python used to like you. Thank you. Xmission. Matt not here? Oh, I guess he's not here today. So Matt's usually here, but he's the CFO of Xmission. People didn't know that. Xmission, everybody know what Xmission is? Your local friendly organic ISP. They will not do deep inspection on your packets. They will make sure that you get your Hulu and your Netflix and your YouTube all at the same tube size, right? So we want the tubes to be the same size. We don't want to pay more for bigger tubes. So Xmission won't charge you more for bigger tubes. They will make sure you have the same tube size. Because again, the internet is a series of tubes. University of Utah is the venue, so thank you, University of Utah. Tech Systems, anybody representing there? Yeah, so Kate's out. She had like a canine-related emergency, so she could not be here today, but they've been sponsoring some of our Raspberry Pi giveaways. They've sponsored our soiree. They've been a very consistent sponsor for us. And we have a new sponsor, Haley from Here Realty, and she's going to give us a quick spiel.
Very quick, I promise. So yes, hi, I'm Haley. I wanted to start coming to these because I specialize in relocation. So I actually was a recruiter and then realized I was doing more relocation and not getting the other side of the deal, so I decided to switch over to real estate. But I work a lot with Tech Systems and a couple other recruiting firms in the area. So if you know anyone that's moving here, or if you say get a job out of state, I have a lot of connections in different states as well, so just want to be a point of reference and a contact for you. And thanks for having me. Yeah,
Woo!
that's it.
Thank you for sponsoring our meetup. If you've ever tried to buy a house or rent in Salt Lake City, you know how easy it is, right? Like, there's just houses growing on trees here. There's so much inventory. No, it's hard. So next time you're thinking real estate, think of Here Realty. New sponsors always appreciated. There might be a sponsor that rhymes with Oogle that will be sponsoring us fairly soon. We'll see how that pans out. Yeah, it's Moodle, right? No, I'm just kidding. It's and then, yeah, all of our stuff is right here. Here's the link I was talking about. All of that stuff is on SLCPython/money. New members, you get to introduce yourself. Raise your hand. Say hi. Hi. Hello. So we're going to go through, and you're going to introduce yourself by saying your name, your occupation, like whatever you're doing, and your favorite cold soft drink. We're gonna keep it PG-13 here. We're not going to talk about alcoholic beverages. If you want after, we'll talk about the merits of a nice cold beer. But for now, we're just going to talk about favorite cold soft drinks. So I'm Ferris. I am the chief backend, not chief. I used to be a chief something, but now I'm just a senior backend janitor at Team. My favorite cold soft drink is a lemonade, just like a nice sour lemonade, not too sweet. So. You're new. Say hi.
Hi, I'm Dominic. I'm a junior developer at Consensus Corporation, and I guess Diet Coke would be my favorite soft drink.
Diet Coke, a Utah original. Anybody else? New.
So, hi everyone, I'm Jotesh Kongara, and I am a software developer for eBay, and my favorite drink would be lemonade.
Lemonade?
Yeah.
You can't just steal mine. Sweet. Who else? Are you new?
Yeah, I'm Avinash Methala, and I work as a software developer at DailyTrack, and my favorite soft drink is Coke.
Coke? Nice. Very, very nice. The dealer track, right? Cool. Oh, nice to have you. Who else is new?
Patrick Thurman. Occupation, I guess, is semi-retired right now. I actually was CIO and VP of IT for a company and got tired and decided I wanted to try development. So, favorite soft drink?
Mountain Dew. That was my go-to. Oh, the summer of Code Red. In the back.
I'm Miriam. I'm a data scientist at Overstock, and I like iced tea.
Iced tea, classic. How many Overstock people are there today? 5? Sorry to interrupt.
My name is Missy. I'm an aspiring data scientist, currently unemployed. Just moved here, actually from Portland. I'll go with root beer.
Root beer. I know you're from Portland, so you want to drop the prefix on that. I gotcha. Who else? Anybody else is new? I could have sworn I saw more new people. I mean, I know Haley's new here, and she's not raising her hand, so. You have to introduce yourself.
Well, you know what I do.
Well, you're in the community now. You have.
Half iced tea, half lemonade. So that's my jam.
There you go. Oh, can I switch mine now? I want an olive moment now. Sweet. Anybody else new? Going once? Going twice? Well, there goes your chance. Who's hiring? Team's hiring. That's the company I work for. We build apps that help you manage meeting spaces and inspire a better workplace experience. They gave me a nice laptop, so I have to, say the motto correctly in elevator pitch now. So, who else is hiring in the Valley?
Overstock is hiring. We're looking for machine learning scientists, machine learning analysts, and data engineers. So basically anything related to data, we're looking for help in that space.
So Amazon is hiring. No, I'm just kidding.
Yep.
More data science, eh?
Yes.
Okay.
Data science, data engineering, data DevOps across the board.
Yeah, sorry, I have to type this on like a tiny screen. Anybody else in the Valley? Anybody know somebody in the Valley who's hiring?
Recursion isn't hiring right now, but we're going to be moving into a new space really soon, and we will be hiring then for probably a lot of things, probably everything. But data science stuff for sure.
All the jobs.
Yeah.
So, hiring soon, Recursion. Pharmaceuticals, right?
Mm-hmm.
Anybody else in the Valley? Hiring? Know somebody who's hiring? Going once? Going twice? You know that Allstate's hiring? there was a posting in our Meetup group, so you can check that out. I'll not mention it now since they're not here. Who's looking? This is your chance to stand up and market yourself and be like, hey, I'm so-and-so, and I'm going to do this.
I have to do it like that?
Yes. Yeah, Bond style, I like it.
I'm Tim Anderson, and I'm looking for a job in doing machine learning, data science sort of stuff. Yeah. Give us a little bit of like background. I have an astrophysics background. Jacob likes that. I know a lot about spectroscopy. I've been playing with. I took a sort of a year off after my time in grad school to just have fun with neural networks, and so that's what I spend all my time doing now. Well, actually, now I'm spending all my time looking for jobs. So I got married 2 days ago because I got married a year ago or so, and my girlfriend was fine with me not having a job and living off my savings, but my wife wasn't okay with that. So
is that still the case?
So we eventually came to an agreement that I got so long to play that I had to actually make getting a job my job. I can only play before 9 or after 5. And so that's probably about enough.
Yeah.
Come talk to me.
If you know somebody who's recruiting, Tim's going to probably get snatched up in the next 30 seconds because he's one of the smartest guys I know. He's done a talk from everything from elliptic curve cryptography to you used like freaking neural networks to figure out how to do a 3D printed Gödel-Escher-Bach like shadow thing.
That one I did.
Yeah.
ECC I'll take them.
This was just for fun too. This was just to do meetups, okay? This is not when like you pay him money.
This is when he was supposed to be writing his dissertation.
So yeah, that's Tim. Anybody want to follow that? Sorry, I'm just kidding.
Follow that well. My name is Missy. Like I said, aspiring data scientist, just moved here to Portland. My background is in civil and environmental engineering, and I decided to make the switch about a year ago, a little less than a year ago. So I've just kind of been diving headfirst into all things data science and Python since January. So it's exciting. We're learning a lot. Yeah, that's my spiel.
What was your engineering background?
Civil and environmental. Do a lot of like petroleum remediation type of work.
So you're new to the Valley?
Yeah.
Do not go to Domo. Okay, who else is going?
Unless you want to be looking for another job.
I have actually heard that before.
Welcome to the Valley. Awesome, who else is looking? Any former Domo employees? All right. Community news, DEF CON 2018. Who's going to DEF CON? Come on. Yes?
I'm not actually going to DEF CON. I'll be in Vegas that weekend.
So you're going to bring a burner laptop?
My sister's going to DEF CON. So.
Yeah. My dad might be going to Nerd Burning Man, aka DEF CON, so that should be fun. Has anybody been to DEF CON before? That's on my bucket list. Like, I think we should get one of those, those party buses that they take down to Wendover? We should get one of those to Las Vegas. Like, just imagine like a bus full of nerds going to DEF CON and we're stuck in the same bus for 10 hours.
6 hours and 9 minutes.
6 hours and how long?
9 minutes.
5.
You guys all know.
No, I definitely would love to go this year, but I think I'm going to put it on my list for next year. Community news, Django 2.1 was released. Somebody pasted that in. Thank you, whoever pasted that in. Yeah, who's still on Django 1.8? Not us. Oh. Yeah.
Python too.
No, never. So if you're still on Python 2, you have 1 year and change left. Like, it's coming. It's coming fast. PyCharm 2018 just came out. Well, I guess it's a new quarter, so new PyCharm. Who's putting these? Thank you. Some mysterious person. Maybe they're online looking at us. Let's see. Any other community news, stuff we should know about? No? Nothing? No, like, major outages that we can laugh at? No companies being bought by Microsoft? No? Sweet. Anybody want to give a talk in September? I'm thinking September we should do 3 short talks. Because I think I want to try doing that format more than one long talk. Like, just kind of have like a beginner talk, intermediate talk, and the advanced talk. So, and the ultra advanced talk, Tim. Yeah? So, we could do that. Or Missy, you could like be like, oh yeah, you want to see Python and environmental engineering? Here's a differential equation to show like why this room is so hot. Yeah. But yeah, if anybody wants to give any talks, these are a bunch of topics that people have showed interest in. This list keeps growing. It is pretty awesome.
I do Pdb.
Pdb?
Yeah, the debugger.
The debugger, yeah.
I didn't know that it even existed for like 5 years. And that
Yeah.
was like 4 out of those 5 years wasted, man.
So if you do that, I found out a few days ago that now you can do import debugger or just debugger. I don't think you have to import it. I haven't tried it yet. It's a new 3.7 feature. Literally just write the word like debugger, I think, or break, or I have to look it up. I'll look up the pet.
Different then?
It's the same, it's similar syntax, like once you dive into it and like are actually in it, but it's built in. You don't gotta import IPDB or whatever. I use IPDB personally. If you're not using IPDB and you're just using PDB, try IPDB.
I did try IPDB, but IPDB, when I tried it, really didn't like, it had weird interactions with Qt stuff I was using, and so it would do nonsensical things.
Well, just don't use Qt.
Is IPDB the one that drops you into an IPython shell instead of...
Yes. Yes, and it has auto-completion. So if you've ever done debugging, you're going to find that to be handy. Yeah, these are a lot of different talks. If you want to do one of these talks, please hit me up. Just send me a message. I think I'll give a talk, a short talk, this next meetup on Doku, because even though it's not directly Python related, I think people would find it very helpful to know how we're hosting our site so that they could possibly contribute or try setting up their own site. One thing I really like is that I'm not reliant on AWS right now, so we're literally paying $5 a month for something that AWS would probably charge us $30 a month for, or Heroku would charge us $50 a month for. So very happy about that. And yeah, or OpenFast. Has anybody used OpenFast? So OpenFast, has anybody done Lambda, AWS Lambda? So OpenFast is the open source version of that, and one of their key demos is they put it on a bunch of Raspberry Pis. And I told people this joke so many times, but right now I have 4. They're named after South Park characters, and I'll just pull them while they're doing a Lambda function, and I always pull Kenny because I like to kill Kenny. So that would be a fun one. I should bring in that build sometime. But yeah, there's all kinds of cool things. WebSockets in Python just got much easier with 3.6 and 3.7. Asynchronous anything in Python would be cool. So yeah, hit me up right after this meeting is the best time, and we'll book it in. Yeah, so tonight's talk is going to be about functional Python, and we're going to take a 4-minute break and grab water and all that other stuff we need to do while we set up.
Does anybody not have a name tag / wristband?
You just need this one. Oh, and you... Yeah. I gotcha. Yeah, man. I did. So you need this and this. And as long as you have the charger, put the charger in here. And was fun. And then, yeah.
That's a nice one. It's way nicer than mine.
So let me see if you're clear on this. Yeah, I got you loud and clear.
And it's mostly in Java and Scala. My boss kind of hates Python. But Bob's on my team, and we both know Python, and I have a true love for Python, and that's a close story to what he said. I started out as an analyst at Overstock, started hanging out with data scientists because it was like the weird math connection, till I realized, you know, I thought I wanted to be a data scientist when I grow up, and I don't really want to go to grad school. So I figured being a dev for a few years would be good first. And I had taken some Java classes at the university before, but I didn't like it, wasn't too into it. I taught myself Python with the data scientists, and that's how I fell in love with coding. So kind of close, but not really, right? I got a job as a data engineer because I could write code. And don't let that fool you. I'm at the point right now, I don't know how many senior engineers or developers there are. How many developers are in the room? Not data scientists, but how many developers? All right, sick, right? And the rest of you are data scientists, right? So I thought I could write code until I started working with a principal dev, and I started working on his code base. And I realized I can't write code at all, and I have a long way to go. So there's my disclaimers. So this is a book on functional programming in Python. Being a data engineer, we do use a lot of functional programming. Not so much in Python unless you use PySpark, you probably will. Jacob could tell you if he uses it at all. I don't know. I'm not on the data science side of things. I'm on the, we're kind of like the plumbers of data, right? Data engineers. We build like pipelines and things like that for people to use. But I use a lot of Scala, and we use a lot of functional programming. But the thing is, Python is the language I love. I'm very familiar with it. I'm comfortable with it. And when I learn a new topic, no matter what language, I always go to Python first to learn that new topic. So I found this book online, and I'm just referencing it because it's about, if you look up top, it's 49 pages long, so you could probably know what I know in about 2 hours. And here are some of the things it goes over, right? And I had a disclaimer of what I didn't go over, but I figured it'd be better to just show you this book. So encapsulation, that's just weird in Python to have encapsulation. I don't understand that. It's not Java. Maybe you can tell me that later, why they would encapsulate or have like anything private in Python. I've never done it. I don't know. Sure, but it's not really encapsulated though, right? We can get into that later. Comprehensions, I didn't really talk about that, right? Everyone should know about list comprehensions. Recursion, I don't think Python is the best language for recursion. I know you can use itertools. I did not go over Tell-in recursion in functional, but which is a big part of functional programming. I didn't talk about it because I couldn't make an example work fast, you know. And if I can't make it work in less than like 10 seconds, which is a long time for a program to run, then I'm not going to talk about it. Callables. These are important things. I probably should have talked about closures. I didn't. Higher order functions in Python are supported really well. And that's what most of the talk is going to be about, is higher order functions. And then decorators. Decorator pattern in Python is awesome. I don't know if you ever use it, but it's beautiful. I think it's one of the most elegant things about Python. So I downloaded this book for free online. I'm not saying that you should go steal a book, but I mean it's there. And then I read this book here, and this was like 50 pages too. And most of the code and ideas that come from this come from these two books. That's part of the reason I'm throwing them up there, because I don't want to get in trouble for stealing people's ideas. Right? So here's my information. You can find this code after the presentation. I'll go check this into my GitHub. Here's some sources to those books. Here's a link to the Pact book that's not free. The other one is free. Oh, I got it for free. I don't know if it's free. Here's some disclaimers. I am not a Python dev. I have never written, deployed, or done any sort of enterprise Python in my life. only in academia, and only writing cool notebooks that do like cool scikit-learn stuff with like Lotus data sets or Iris data sets, right? Which is far from actually building anything that works in real life. So I'm that guy. I'm kind of a Python hacker. Any Python hackers in here? Any analytics types that get into Python trying to figure it out because they're good at statistics and they're like, oh, I can do this cool stuff in R and Python, and you get all hung up on the data science train. That's my story, right? Before I learned I did not want to go to grad school. I use functional programming daily, but I'm still fairly new to it in the last 6 months. So part of volunteering to give this talk was so I could learn more about it. I'm not trying to sell functional programming as the ultimate paradigm. If any of you ever read anything on Scala or Lisp or Haskell or anything, there's like these functional programming like types that are just like object-oriented programming is so stupid and it sucks and it's hard to test and you should never mutate anything and blah, 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 blah. I am not like that at all. I use a lot of objects. I love object-oriented design patterns. I don't, I don't have any problem with object-oriented programming at all. In fact, half of the code I write's in Java. How could I have a problem with object-oriented programming, right? Functional programming, it might help your style. I've noticed that it does kind of like trick out your code a little bit. I call it kind of skateboard tricks in Python. It gives you some little like flair, you know what I mean? Which I think is cool. And the last one, functional programming, is fun, right? So it's more like functional programming, right? Emphasize fun, right? No, it's fun, it's fun. We're going to have a good time, trust me, right? And even if you don't learn anything new, you might win something, so, like I said, I don't go over all the concepts. The concepts I think Python does really well. Anonymous functions, of course, lambdas. Lambdas are a big part of my life in Python, Java, and Scala. I use lambdas in all 3 languages. They are not going anywhere. Anonymous functions are a big part of data engineering and building pipelines and pipelining data sets together for transformations, right? Higher order functions, it supports really well. Decorator pattern, beautiful. The currying pattern, you got to do a few tricks. And memoization, and I don't know that memoization is actually a functional thing, but this PAC book talked about it because they were trying to use it for recursion, and it didn't work very well. But we're going to go over some memoization. Anybody not know what memoization is? Sick. All right. Well, this is good then. Important topics not covered worth looking into are monads. I have some code on monads if you want to talk to me about it after the meeting. I just don't fully understand it, and I didn't want someone that's really smart to ask me a really tough question and like I'm just getting caught with my pants down because I don't fully understand it. Tell-n recursion, it's kind of a nightmare in Python. And determinism's a rough topic for me. I'm the guy that got a C in real analysis. Math is not my strong point. And functional programming is very mathy, right? So all the math PhD types love it, right? They love it. They think it's awesome. What? Yeah, but I'm not good at it. Math and statistics, and I write code now, right? So a function is exactly what you think it is. Speaking of math, right? F of x equals x. I mean, that's that. You want your functions to be one-to-one. You don't want them to have side effects. You want them to do what they say they're going to do, right? You plug an input in, you get an output. And most of all in functional programming, you don't want to change the state of anything that's outside of the function. And that's one of the biggest things that I think is super important in functional programming. You don't want to mutate states, right? You want to, if you do like data transformations, if you pipeline data together, you don't actually mutate the original stream or data set or table, right? You just reduce it or you map it or you filter it into something else, right? So that's pretty important. So just to get kind of started, this is a bit of review, or maybe it's something new. Maybe some of you haven't seen this before. Most of you probably have. So we're just going to go for a basic function, right? And we're going to talk about anonymous functions and UDFs, right? Anyone unfamiliar with the term UDF? Right? So I was too, and all these people like Miriam were like throwing around the term UDF and Jacob, and it's just a user-defined function, and it just, we'll talk about it more, and it means when you're operating on a set or a collection of objects or data that you wrote your own function that's going to operate on that. Like, it's kind of the best way to put that, right? The simplest way I can think of. So this is technically not a UDF, this Pythagorean's theorem, right? This is just a function. And of course, this returns what you, well, first of all, I better not skip. Yeah, see, I'm skipping things already. This returns, right, what you think it would. The square of 3, the square of 4, the square root of that, or add them together, and the square root of that is 5. Now, here's a way that you can write Pythagorean's function, right, or theorem in a lambda, right? Anyone not familiar with lambdas? One person. That's, yeah, I figured that everyone would know about lambdas, right? So, real quick, lambda is just an anonymous throwaway function. So, if I write a lambda, like I wrote lambda Pythag here, equals this lambda expression followed by 2 parameters, and then I tell it what I want the 2 parameters to do. I can call this function here, and I can plug those 2 parameters in, and it'll return something, right? Lambdas can be used as parameters to other functions. So I can do this function up here, the Pythagorean's theorem, and I can plug in lambda functions in it. And what it's going to do is it's going to take the results of these 2 functions and return a value, right? And then also, what might be a better way for you to do is to catch it, right? So I have L1 and L2 catching those functions, and it'll return the same thing. Ternary operators. Anyone unfamiliar with ternary operators? No? Cool.
What's it?
Ternary operators are a lot cooler in something like Java or C, where it actually shortens your code a bunch. In Python, it doesn't really shorten your code.
Yeah, it does. It makes it pretty short.
Okay, it makes it a little bit shorter, but what it's really good for, and what we'll talk about, is you can make a declaration as a declarative statement as opposed to an imperative statement. So the ternary operator has this condition. It returns a Boolean, right? Condition is true, if condition, else condition is false, right? So here's the example here. I got x equals true. I got the state equals 1 if x, else 0, and this should return 1, right? If I wrote it right. Or true, sorry, right?
State should be.
No, yeah, I should. Yeah, that should be. You're absolutely right. State should be 1. Thanks. So I'm an awesome guy. I forgot about that I was giving this talk till like 3 days ago when Jacob reminded me, and I put this whole thing together at work today on the clock. So I'm glad I have so many colleagues here, you know, that can go tell my boss this. No one likes my boss though, so no one will tell him. So it's fine, you know. So this is a ternary. This is a ternary, right? 1 if x, else 0, right? And that just makes it declarative, right? And when you're writing lambdas, it's actually pretty cool. It can kind of pimp out your lambdas a little bit. It can give it some style, right? Which cool. I'm a fan of cool-looking code, right? So here's a factorial function. The factorial function that we all know and love, right? Runs recursively, has a base case, and you know, this should return 24. Yeah, I mean, I did do some math, Jacob, you know. Now, here's what I call it. It's like a ternary factorial, right? So I have lambda n, and then I put the ternary code in there. And I think that using ternaries in the functions is actually the preferred way because it makes it more of a declarative statement, right? And this just does the same thing, right? So, like I said, for a lot of you, this is review. And here's my question, and this is for Jacob, right? Are ternary operators always useful? So here's a calculator I wrote just imperatively, right? They both return the same thing. Here's a ternary calculator, right? And if you look at it, it's a little bit shorter. You have to use these backslashes if you're going to kind of chain ternary statements together, right? Or it won't work. But I'll leave that up to you. Is it always useful, right? I don't know that I think it's always useful. I don't think that I'm going to go and refactor every piece of code I have and write it in a ternary style as opposed to like an imperative style or whatnot, right? But these both return the same thing. And this is maybe a little bit shorter, right? Map. Anyone unfamiliar with map? Perfect. You can tell half the room, most of the room's data scientists, right? So here's and this is a UDF, right? So I'm gonna write this function. I'm gonna write what I want the function to return. It just takes X and adds it to itself, right? Pretty straightforward. And I have my list of ints here, and then I'm going to take a list, I'm going to map this function onto it, and then I'm going to put a list in here, another collection of data or objects. Everything in Python's an object, so I can just say objects and get away with it. And it will map this function up here onto the collection of objects. And what happened here? Oh, I didn't click it yet, right? So see, pretty straightforward. You take this map, you put it together, right? There's a lot of wax on, wax off. We're going into the weeds soon. Don't worry. Lambdas is a parameter for map. Again, just another way I trick out my map function. Instead of writing a UDF, which if you're doing any type of like data pipelining or anything like that, this is usually the way you would do it. You would do your transformations in lambdas as parameters, and you wouldn't define all your functions, right? Or if a lot of you are using pandas, you're all data heads, you're using pandas, you would just use whatever built-in panda function goes onto the data table, right? Which to me makes sense because it's Python, and Python should be short and pretty. I mean, that's just my opinion. Filter. Anyone not familiar with filter? You're just saying that, right? No? So a filter is just like, here's my UDF for filter, and a filter takes the function to apply, collection of objects. That's the form it takes, and it just, if I'm going to filter something, if I have a row and I had like all names that were girl and all names that were male, maybe this is a bad example because gender, I'm going to leave gender out of it, right? All zeros and all ones. And I wanted to return all ones, right? I wanted to create a new data set that returned all ones. You had a question?
Aaron, how is filter different from map?
Filter is a lot different from map. So what map does is you take a function and you map it to that collection, right? So map took this lambda right here, lambda x, and what we do with x is we add it to itself, and we added, right, so we added 1 to 1, 2 to 2, 3 to 3, and it added to everything in the collection. Filter is going to, if you look at this, what a filter does, this one returns all the evens. So it's actually going to filter out all the data that you don't, or it's just going to return what you want it to return. Similar to a where clause in SQL.
Isn't it just applying a function to a list, though?
And it's true.
But it has to.
If it's false, it throws the thing away.
Right.
So the difference is one of those functions returns a value, the other returns a boolean.
I get it.
Map will just return all of the values, and if you pass that Eden's function in a map, it would just return true, false, false, false.
Yes.
Whereas filter just gives only
true.
That's why I work with these smart people to help me answer questions that I don't know.
Another way to think of it is that for the map function, if you have a collection of n elements, the map is going to give you n mutated or transformed elements back. Whereas the filter, you're not going to get, well, you might get n elements if every element of the list was true,
but otherwise you get a reduced list.
Okay, thanks.
Right. Perfect. See, there it is right there. So it just return the evens in the collection. Right? And just a tricky filter, just using the lambda as the parameter. Anyone do martial arts in here? I know that's a broad question, but there's a saying in martial arts, right? There's a saying, I'm not scared of the 1,000 kicks you practiced once. I'm scared of the one kick you practiced 1,000 times, right? I feel like if all you did was map, filter, and reduce, that you're more dangerous than currying and like memoization and the other topics that we could talk about, right? So if it's a little redundant, I don't apologize. Reduce is different. Reduce returns kind of an aggregation. Am I right, Jacob? I'm making sure that Jacob's nodding his head. Right? So in this case, when we reduce it, we're going to return, I'm going to take the, so first I'm going to import func tools because it's not something that you can just do in Python without importing func tools. Right? And my UDF here is going to multiply x times y, which they usually call that like left-hand folding, right? So it's x is going to be the incrementer, and then it's going to multiply by the next one, and then it's going to go over in the list. And the big thing that functional people will tell you is that functions are easy to test. So I have a product here that's, you know, it's got 1, 2, 3, 4, 5, 6, 7, 8, 9, a list here. And I'm going to assert that the product that I have that reduces that list by multiplying everything together equals my other function, factorial 9. Beautiful, nothing happened. That's a great thing. So the big seller that a lot of functional types will tell you is testing a function is easy. Now, I've never really tested a really like hardcore function. You know what I mean? I've written a lot of functions that have been deployed, but they're all just small pieces of like data operations, right? They were pretty easy to test. So I'm sure there's some edge cases that you could think of where they're not easy to test. So we asserted that. Okay, so here we're going to kind of get in. That was just kind of like a review, make sure everyone knows that, make sure that we got that. Practical functional programming. Now these are toy examples. Like I said, I've never used Python in production. I could think of PySpark examples where a lot of these things would apply to, and I could think of real life data examples where this would apply to. Like I have a list of characters here, and I just want to count the A's, like a typical, you know, or maybe you're a data scientist and you break up your big string and you want to tokenize everything and you want to do some sort of word count, right? So I'm going to write it imperatively. So I wrote it imperatively, and here's my list. Spoiler alert, there's 5 A's in there, right? And I'm going to set, I'm going to do this like imperative 101. I'm going to set an incrementer, right? A count equals 0. Then I'm going to do an iterator for I in characters, right? A count plus equals I dot count where it's A, right? Pretty classic imperative style. and there's 5 A's. And for the record, I don't think that there's anything wrong with that, right? Sean, you're looking at me strange.
What is that count method? What class does that belong
Dot count, it's a native Python
to? I
class.
just never
Yeah, it's just dot count. I don't know. Don't ask me too many hard Python questions.
I think, if I'm not mistaken, it's when you have an iterator variable, you get that as a bonus. I'm not sure.
Or is that just part of the regular string?
Yeah, that's what I'm not sure.
I think it's part of the regular string.
So, let's just, okay, I wrote it somewhere in the code and you can't see it. Let's just say that. Either way, it counts to A's, right? So, I did that. I made this library, Sean. Right? But here's how we would do it functionally, right? So we look at this code. You want to get rid of the incrementer, and you want to get rid of the for loop, and you want to make it declarative. So line 31, right, I have a count functional equals a reduce function that adds a plus b dot count a, right? And 0 is the incrementer here. I probably left that out as the first, so it's going to count from 0. It's going to go to the first a, and then it's going to add that to the next b dot count a, and then that becomes a, and it goes through, right? And let's just assert that it equals 5. It does. We're good, right? Again, I don't think that like this code is bad or there's anything wrong with it. I do think that this code is just, it's a lot more slick, it's cooler looking, and if you're working on data, you didn't introduce any mutated states, right? But it's not that one's better than the other.
Question.
Yeah.
Do you know if doing function style reduces the type checking overhead that you have from the deployment?
The type checking?
Yeah, does it reduce the type?
Dude, I write in Java, man. Don't even ask me about type checking. I'm going to say...
It might actually be faster.
Right. It might be. So that's a question I don't know about. I don't write in a dynamically typed language for a living, right? So that was a hard question that I can't answer. Do you?
I'm sorry.
Well, it also would reduce memory footprint, right? Because you got the list. Although I guess no, they'd all be the same.
I don't know. Yeah, I don't know that it would reduce memory, right? I don't know. I do know that, like, let's say you have a stream and you're doing a neural network operation, and you know, I built a stream for you, and you want to run your cool neural network stuff that you built in it because you're smart as hell, and you're gonna make it 3D print, all kinds of cool shit, whatever, right? We don't want that schema that's defined for that data to mutate, right? We don't want to introduce anything. We don't want that to be mutable, right? And that's the thing that I like. Even the object-oriented code I write in data engineering is mostly like builder pattern and things like that, where you can't really mutate the classes, right? So that's more where I think functional programming is beneficial. I don't know that it saves you memory. I don't know a whole lot about it. I read a 49-page book. It's free. You can find it online, right? Here's a cool, you know, I call this the imperative average dopeness list. It's some hip hop artists here, right? So I have a list of dictionaries. Where I would use something that I'm about to write now in real life is probably on like a big JSON structure that like I wanted to reduce to elements of JSON that I actually wanted to pull in to a data object or into some sort of data frame that I want to use, right? So I made up one because it's talk. I'm not graded on it. I'm not paid. So I'll talk about, you know, hip hop artists, and I have a scale of dopeness. So I have the artist, and then I have how dope they are on a scale of 1 to 5, right? So I have Outkast is 4, MF Doom is 5. If you don't know MF Doom, you should, right? Now we get down to Rakim's so dope that he doesn't have a scale. right? So we couldn't include the scale of dopeness here, right? So what I want to do here is I want to find out the total dopeness for all this data. I know that it's there. I want to find how dope are all these artists, and I want to find out the count of how many people are on the scale of dopeness, right? And here we go. I'm going to set my incrementer variable, right? Which will be the first things to go when we write it functionally, right? So I have total dopeness equals 0, count dopeness equals 0, right? Basic way to increment. So then I iterate through the hip hop artist list of dictionaries, right? And I say if dopeness is in the art, total dopeness plus equals, right, this key returns the value, and count dopeness plus equals 1, right? And then I say as long as it's greater than 0, I have an average dopeness, because I want the overall average dopeness of all my artists, right? I want to know that I'm in the above average dopeness overall. So and this works, right? Again, 4.2 on the dopeness scale, not bad, right? Accounting for my outlier, Rakim, who's so dope he's not on the scale. But I'm going to write it functionally. And the trick to writing, when I'm dealing with data, and I'm trying to write it functionally, a trick that I try to think of is I try not to think of iterating through everything, right? I try not to think of doing operations on every piece of data. What I try to think of is what data do I have, right? And a lot of times when you're dealing with big data sets, you have a schema. You don't even know like exactly what the shape of the data is. You just have a schema, right? And what do I want the data that I'm going to build to look like, right? I've heard it like this, like when you're writing something functionally, if you're writing it imperatively and you're playing fetch with your dog, you're telling your dog how to fetch the ball. You're saying, run, I'm going to throw the ball, run, fetch it, and come back. When you're writing it functionally, you're just throwing the ball. And they're fetching it and coming back. So instead of telling the code how to do it, you're telling the code what you want, right? You're saying, this is what I want, right? So this is what I want here. I want dopeness, right? And I'm going to, instead of trying to chain all these lambdas into each other, because the problem you can have when you're chaining like 10, 11 lambdas onto one thing, it becomes so cool that you can't read it. And anyone that has to work on your code base hates you, and like, you know what I mean? You have to document it super well. It's so cool you can't read it, right? So it becomes like Rakim. It's off the scale of dopeness, right? So here, right? All I want to do is this first for loop in the code. All I want to do is the first for loop. I want to get rid of the incrementers, and I want to do this first for loop. So I'm going to say dopeness equals this list that maps a lambda x such that the x dopeness key exists, right? And I'm going to filter it such that dopeness is in the list, right? And I put in my list, and all that should return, right, are all the values that exist within dopeness, right? So here they are. Then I'm going to take this second part here, okay, and I'm just going to get the average. So I kept my if statement, right? And all I added is I said if average dopeness 2 equals reduce lambda xy such that x plus y and dopeness, right? That's the list. And I'm going to divide it by the length of dopeness. It's just an average function. It just looks really fancy, but it's just basically taking the sum of all dopeness and dividing it by the length of dopeness, right? That's it. It's pretty dope. And let's see that it works. Yeah, it works, right? returning functions from other functions. Now, here's my caveat. So this is where it might get in the weeds a little bit, and you might ask me hard questions that I can't understand because, like I said, I'm not a Python developer, right? But these are the cool skateboard tricks of Python, I think. Now, everything previous to this is actually useful in my life, and I use lambdas every day. Not maybe in this form, but every day, right? This stuff I've never actually written outside of like this talk, and I think it's really cool. So just throwing that caveat out there. So returning functions from other functions, right? So I'm going to write a function that spits out a function, right? And this gets really nested. So this is my example, how to give a talk at a Python meetup. So my first lambda, A, go against better judgment and volunteer to give talk. Okay. B, research topic for the talk. C, hack some code together for presentation. D, make it pretty. E, speak at Python meetup, right? So there's my steps of lambdas there. And we can just check that they all work. Boom, they all work. So here's what I'm going to call a meta function, right? And this is where we're starting to get into decorators, but not quite yet. I'm going to write a function that takes a bunch of vargs, right? And they're functions. And I'm going to return those functions. So what this function is going to do, right, is it's going to take all those functions and then it's going to iterate through them and return them, right? So that's pretty, I think it's pretty dope. There you go. Boom. Beautiful. But here, we're not, like, we can do even better, right? We can write a function that spits out another function that makes all my functions run, right? So this is got an inner function in it, which, again, is one of the qualities I think is so beautiful about Python. You can put inner functions inside it, and you can wrap functions. And this is my give talk 2. It takes a bunch of vargs. It has an inner function that basically does what this function just did here, and then it returns that inner function, right? So now I'm going to have talk equals give talk 2 with all my functions. So now talk is a function, right? And it does that. Boom. Really beautiful. Useful, I don't know, but really cool, right? Anyone watch people do lambda calculus online? Like, I'm one of those dudes. They return all kinds of weird things. I think it's cool, right? So here's my question for you Python guys, and I put this in here on purpose, is why is it when I assert these two functions, it returns both sets of functions? And if you don't know, I'm asking that because I honestly don't know, right?
Well, you've called the two functions. So you're calling talk, you're calling give talk.
Right.
And because each of those functions executes all of the quit statements, it has to evaluate those two functions in order to assert that they're equal.
So it's returning, each of those return none. They have a none return type.
Yeah.
So that's just assert none is none.
Right. Okay. So it doesn't do it with any of my other functions, right?
Well,
like
because the print is a side effect.
Oh. So I messed up my functional paradigm. Damn it! Disregard everything I said. It's time to go home. Right? Okay. Well, good. Well, let's just forget that I asked. Let's just comment that thing out. All right. So I was going to talk a little bit more about some useful things in functional programming, but Sean came up to me. Sean's my mentor. Sean's taught me a lot about Python, Scala, and Java. He speaks like 5 languages. He's been an engineer for like 20 freaking years. Now he's a data scientist. And he said, are you going to talk about currying? And I was like, I don't think I am. And he's like, you should. And I'm like, okay, Sean, I will. So here's currying. And note, Sean Siemens made me do this. So there's Sean. He made me do it. Currying is actually pretty trivial, though. It's just the way that, so if you remember from your math class, whatever last math class you took, f of x comma y equals f of x y. You can write it that way, right? It's just notation. And the example is that f of x y equals x plus y implies f of 1 and y equals 1 plus y. Pretty straightforward, right? So I have an adding function here, right? And I'm just adding 10, 100, and 1,000. Typical function, pretty easy to see what it does. Takes 3 parameters. They're ints. I don't know how it knows that they're ints, Jacob, with your types and stuff, but it doesn't tell me. I didn't type int anywhere, and it doesn't make me, so that should be a talk in itself. Type safety in Python, does it exist, right? I'd say no.
It checks every type every time.
Yeah, at runtime. So what we're going to do, what currying kind of does, is it binds the function. And if I want to take this adding function and I want to plug 10 in for A, I can do that, and then I can save that function, and then I can put the other 2 parameters in later, right? Which is, it's kind of cool. Sean's probably used it in real life because he's a way better dev than I am, like way smarter. I've never actually used it, but it's cool. So we'll talk about it, right? So we have to import func tools again. I think I already did once. And there's a function called partial. And here's my first partial function. I'm going to call it adding 10. And I'm going to set it to equal partial. And what partial does is it takes a function and a value, right? So I'm going to take the adding function, and I'm going to take the first value, okay? Well, what happened here?
One more option.
Did you make it?
Which one did I miss?
Oh, you didn't do that one yet.
Problem with notebooks, right? Now note, these are, the adding 10 is not a value. It's a function. It's a function, just the first parameter is taken, right? So you can see I got functools.partial, and it shows it's a function, and it has a parameter 10 in it, right? So I'm going to do my second partial function, and I'm going to adding 10 and 100, right? And partial, and then I'm going to put in the previous function that I called that already has 10 for the first parameter in it. And then I'm going to put 100 in it. So now I'm going to have a function that has the first 2 parameters filled. Okay? Boom, it worked, right? So we got 10 and 100 here, right? Now I'll print the result. I'm going to do adding 10, 100, which is the previous function, and I'm going to put 1,000 in for the last parameter, and voila, it returns the same value up here. Pretty cool. We'll assert that it works. I mean, there's no return. I still don't understand. You can explain it to me later. I don't know what I'm doing wrong. But this is one of the most cool things in Python, right? Anyone use decorators ever in Python, right? They're really slick. And I wish this kind of stuff existed in some of the other languages I use. If you write annotations in Java, it's not the same thing as writing one in Python. It's something completely different. So I'm going to write that same function, but I'm going to do kind of a UDF where I define this curry function. I take an inner function, right? And what this signature does here is if you do signature and you put in a function.parameters, it'll just say if it only has one parameter, then we're going to return this function, right? So it's kind of a base case. You can think of it that way, right? And then I'm going to return the function, so it's recursive. I'm going to return it, and I'm going to do partial. I'm going to take the function I plugged in and the argument, right? And then I I return the outer function in the inner, and then I return the inner function in the outer. Right? Everyone got that?
What?
It's a little strange, I know. Right? So, I'm going to do like I set test curry equals to curry adding, and I'm doing it this way, and we're going to go through the steps here, and boom, it works. And I'm showing you this because basically when we get to here, if I take this at curry notation, so I put at and then I put the function, and then I write a new function, it's basically the same thing as doing test curry equals curry adding, right? It does exactly the same thing. And it's a lot more elegant notation, right? It's more Pythonic, more Pep 8-ish, if you will, right? And these do the same thing, right? So currying, really trivial, right? F of x and y equals f of x, y, right? And you can plug things in and use them later, right? You can do partial functions. Memoization. So when I read about this, they were trying to kind of use it in terms of telling recursion, and I couldn't really make it work. I won't say that Python sucks at recursion. I don't think it's the greatest, but I definitely suck at writing recursion in Python. So better to take the heat on me and my crappy coding skills. Because some of you might do something real Pythonic and cool that I don't understand, right? It's the beauty of this language. So I have a prime number function. It's kind of a mess, so just know that it returns the largest prime number, right, in number. So I give it a parameter n, right? In this case, 10,000. Well, I didn't run this. And it took a while to run, right? It got hung up a little bit. It took a while to run. So what memoization does is it actually it can take the value that the function spit out last, and it can cache it, and we'll cache it in a dictionary, and then it can save that value, right? And then if you do that same call again, it's instantaneous. Or if you go a little bit bigger than that value, it doesn't have to go backward. And that's why people would use it recursively, because like if you wrote a Fibonacci sequence, and anyone that's been in algorithms class and your teacher's a smart ass and is like, write Fibonacci for 1 million, and then you get a Stack Overflow, right? It would take the last value and it would keep caching it and then just add after that, right? I can't figure out how to make that work really well in Python though. So if anyone knows, please share your code with me and teach me. So here's my cache function. I'm going to call it memoize. It takes a function. It takes a dictionary. The cache is a dictionary. And it's got an inner function that takes args, right? It has a couple of statements. If it's in the cache, return the cache, right? So if I just did this and it's in the cache, return it, right? Or the argument equals func, and a bunch of args, right? So I'm going to return that cache, and then I'm going to return the inner function, right? And I take this memoize function, and then I wrap my prime number function in it, and it should speed up things immediately, right? So this 991 here actually didn't have to go back to 1, right? It started at 997, and vice versa. Now, if we do this, I don't know, that's like 100 million or something, it's still going to take a while because, well, it didn't take too long. But now, it's instantaneous, right? It's just got the value there and it just spits it out. If I threw in one more 0, it would still take a long time, right? But not as long as it would if it didn't have that cache.
Is memoization just an inherent part of Python as a language, or did you do something in your function to activate it?
Yeah, I built So back up here, this is just what I named the function, and then this cache is just it's a hash table or a dictionary, right? And I'm going to write this function here, and what it does, it takes these vargs, and it's if it's already in the cache, right? So if prime number 909, I don't know all my primes. Like 313 is my favorite prime number, so I know I'm nerdy. I have a favorite prime. So if 313 is in there, boom, return. If 313 is not in there, right, keep going. Then when that's done, store it and cache it, right? And then I just took this memoize function and I wrapped the prime number function with it, right? So you can think of the inner function as it's acting on the prime number function when you decorate a function like that, right? Let's see if our last one's done yet. Nah, it's still working. Right, so it's not magic, it's not like super spectacular, but we are scaling up quite a bit here. So that's it for me. I made it an hour. I didn't choke too hard on too many questions, Jacob. Any questions?
So is filter any different actually than just the I can't remember what I call it, the square brackets with the if at the end.
List comprehension?
Different than just using conditional if at the end of the list comprehension?
So, list comprehension, so a filter doesn't necessarily have to return a list, for one.
Well, so
right?
the filter returns a generator?
It could,
So you have to call
if you wrote it that way. I mean,
if you put a generator in, it'll give you back a generator.
I mean, there might be some technicality with generators and iterators in Python that I don't know about, but from what I understand, yeah, you could yield a bunch of numbers. You could filter. So if you had a data source here and you were generating, right? You were using a filter as a generator. What you would do is, let's say you have all these numbers here, and you wrote the one that I said only take the evens. Then it would only generate the evens. It doesn't have to output into a list. A list comprehension, from what I understand, it could be wrong. Jacob, guys, tell me, has to return a list, right? It's also, and I'm not against iterators, but from a functional standpoint, it's also got an iterator in it, right? I wrote a few iterators in mine. Java Lambdas has a for each iterator. Scala has a for each iterator. All the Spark functions have for each of them. So I don't think anyone's completely iterator free. But from like a functional standpoint, you wouldn't be using an iterator, right?
The filter wouldn't be using an iterator?
No, it wouldn't be.
Generator, I mean, the generator's an iterator, right?
Generator's a generator, from what I understand. I mean, I don't know if it's subclassed by iterators, or I don't know enough about the Python under the hood.
I think that functional integrator tools do a little bit of optimization, so there's less of like fact checking and stuff you have with generators.
That's a way better answer, because like I said, I don't know the inheritance system of like generators and iterators and how they, you know what I mean? Like,
I think I know what you mean.
Right. Like Java hash set inherits from this class and blah, 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 blah. Like, I don't know how that works in Python. What's under the hood of the generator. But you could reduce it and return it as a generator. You could generate your output, is what I'm saying. Where a list comprehension returns a list. Right? But I think list comprehensions are like super sweet, and I use them all the time, especially when I'm doing Panda stuff, and I think they're sick. So it's not like a preference. Just maybe style choice, right?
I still got a question about reduce, because I feel like I've used it and I still don't get it. What's reduce?
Reduce, so one of the things that we didn't really talk about, because I didn't really know that might be a good example, I didn't really know how to bring into context, is like lazy evaluation, right? So if you do lazy evaluation, and like it's something if you're a Spark programmer, you use a lot, right? So let's say you have this list of data, this collection of data, right? And you want to do these transformations on them, right? So we don't want to call them, and that's the thing, we don't want to call them mutations because we're not actually mutating the original data set. We're just transforming it into other data sets. So I have a list of A's and B's, and I want A's and B's and A's and B's pluses, right? A pluses and B pluses, right? And I want only the B's and B pluses. So I filter that into B's and B pluses, okay? And then I'm going to filter it again. It would have been easier to just filter it, but just bear with me. Then I chain another filter to it that only gives me B pluses. And then this is running, right, like on a set of nodes, right? So it's not actually evaluated yet until I call a reduce function on it, where reduce, and I say, what do I say with my reduce function is I want to add, I want the amount, I want the sum of all B pluses, right? So it's an aggregation, right? So if I have a list, 1, 2, 3, 4, and I do a reduce on it, I'm going to say, give me the product of the list. Give me the sum of the list. Give me the average of the list, right? And it's going to be an aggregation. And in most cases with functional programming, when you have lazy evaluation, it's the last step. And you can't go any further than the aggregative step or the reduction step, right? So after, if you look at this here, man, I wrote a lot today. Let's see.
You getting real work done there?
Yeah, I did. I worked on some site test stuff. And yeah, I did some stuff. I talked to you a little bit, hung out with you. Where did reduce go? Okay, so if you look at reduce, this is working on a list, right, of 1, 2, 3, 4, 5, 6, 7, 8, 9. So let me take, let me add, if I just say product here, which is what catches my reduce function, it's just going to give me the product of all the numbers, right? I can't do anything further from a data standpoint with that unless I want to break it into bits. And I'm not that cool, you know what I mean? So does that make sense?
Yeah, that makes a lot more sense.
If I might offer another example, if you were to substitute the word addition for multiply in that def statement in 28, instead of returning x times y, return x plus y, then the reduce function would return the sum.
Right.
Or the average, or what? Yeah, it's
kind of a, if you have it's kind of a way of substituting. It's a function that operates pairwise throughout the list of elements, or accumulating, aggregating the operation of all those elements.
And it assumes that you're doing some kind of computation. It's not categorical variables.
No. So in the sense that like I use it, it's the last step of kind of like the chain of commands on the transformation usually.
Is that what all the hotness about MapReduce was like 10 years ago? Like every other article would be like, oh, we built a MapReduce server cluster.
In the big data world, MapReduce means like distributed MapReduce.
Yeah,
okay.
I mean,
the ideas from here.
MapReduce,
okay,
like
it's the same idea but distributed.
Exactly, it's just on a problem that's too big to work on a laptop.
So here's my offer to that, right? So MapReduce, like Bob is a hell of a pig programmer, and he can write pig script for days. So functional programming is for people that don't want to write pig and want to use Spark to do MapReduce for them, right? So Spark kind of replaced MapReduce with these distributed sets of doing work, right? So that's exactly why I write this way, so I don't have to do MapReduce. I do map and reduce, though.
Awesome.
Anything else? Sweet.
What dopeness score would you give Dr. Octagon?
Dr. Octagon is definitely, I mean, half shark, alligator, half man. That's probably, I don't know, man. His cool Keith's a 4. I mean, probably Victor Vaughn status, I mean.
Nice. Now
Probably Victor
you're
Vaughn
changing your
status.
types of dopeness scale.
No, man. So that's okay. Here's an example of a non-mutable state. Cool Key, Dr. Octagon. Boom. There we go. Transformation, right? MF Doom, Victor Vaughn. That's like functional programming 101. King Ghidorah, right? Just changing personas of the same person, right?
Nice. Well, that was really informative. Let's all give Aaron a round of applause. Thank you so much. Awesome. I think I learned more Python in one session than I have for a long time. So I'm an imperative guy. So this is a cool talk.
I mean, I am too, mostly.
Mostly.
Like I said, I've never used half of that stuff. I've never used currying in real life, so.
I'll grab this guy.
I might have been too cool now.
You guys stay there.
I know, it's hot up there.
All right.
We got differential equation. I heard that's because they can't keep all the rooms the same temperature at the same time.
I don't know.
They're actually talking about that problem. Because of the airflow in the building.
Oh yeah.
It's like a safety, like you can't keep all this. I don't know if that's true. Don't take any, like most of what I said tonight, don't. Other than Rakim is off the scale of dumbness.
All right, we're going to pair program a little to do our raffle. But it's probably not going to work out, but that's okay. What was the highest number? Who has 21? 22? 23? 24? 25? Who does not have a number? You have a number? Okay, you're 26. You can still win. You're here. You participated. But if you win your own prize, that would just be hilarious. Okay, so there's 25 people. We're going to put number of Pythonistas equals 25. Should I write this? I should probably write this functionally, I feel like, but... See, this is why we pair program, right? Let's see, 0, 2, because I'm 0. Num Pythonistas. Sweet. Does this look good? Can I put this in a peer review? Yeah? Let's merge it. Sweet. Do you want to hit enter on this? Aaron? No? Number 18. Yeah, congrats. So you get to come up. You get to pick from one of these 4 prizes. This is a mystery box. If you do get the mystery box, you have to open it and show it to everybody.
Oh, why wouldn't anyone ever not pick the mystery box?
Right?
Look. A Raspberry Pi.
A whole Raspberry Pi kit. Ooh. Thanks, Haley. That was our sponsored prize, this meetup. Do you want to put it in front of the camera?
Oh, in front of the camera.
Okay, thank you.
Okay.
Sweet. Oh, and your second
no,
prize.
sorry.
That's okay. The second prize is you get to hit enter on this, so. Yeah. Wait, come back.
Oh, you're talking to me?
Yes. Go ahead. Number 14. Yeah. Sweet. And we got to see which book you pick.
Oh, let's go for the hard one.
The hard one, hands-on machine learning.
Hands-on machine learning with scikit-learn and TensorFlow.
Awesome.
Something I need to get into at some point.
And your second prize is you get to hit enter on this.
9.
Number 9. Yeah. Sweet. And what are we going to get? Boom. Introduction to Machine Learning with Python. And you get one more prize. Enter. And number 12. Woo! And the illustrated guide. Yeah, no worries. Thank you all for coming. Let me double check. Anybody know off the top of their heads when the next meetup is?
Next month.
Well, yes. Technically correct.
Too far away to think about.
It is the 5th of September. That will be a Wednesday. If anybody has meetup ideas, please grab me. Or if you want to give a talk. Remember, this next one, I think we're going to do 3 talks, so there'll probably be about 15 to 20 minutes each. So you don't have to do a long talk. You can like teach yourself something and then teach everybody else. Okay, so just come here and hit me up. Oh, and Jacob's meetup is in 2 weeks, right?
Oh yeah, yeah. So we're doing another meetup. We're doing a intro to, well, just
the Maslow's hierarchy, or sorry, data hierarchy of needs.
Hierarchy of Data Science Needs by Dylan Gregerson at Overstock on August 15th.
Right.
But actually, I was going to say, I'd be happy to give a short talk on how to package up your Python.
Ooh, Python packaging. Sweet. Come over to the front before I end this, and then, yeah. And if anybody else has ideas, just grab me, and I'm just going to be cleaning up. And yeah, have a good one. Drive safe. If there's extra pizza and you're a student, steal it. If there's still extra pizza after that, also steal it, please. So take it easy.